Imagine standing in a universe that has never seen light. No stars, no planets, only endless darkness. But that darkness isn't emptiness. It's the very beginning of everything that would one day become the cosmos.
Before the first stars were born, the universe held strange distortions, where gravity squeezed reality itself.
In those ancient distortions, matter and energy were trapped so tightly.
We call these mysterious regions black holes, gateways to gravity's most extreme frontier. Have you ever wondered what really happens inside a black hole? What lies beyond that invisible veil?
It's not a hole in space, but a region where gravity bends the very fabric of the universe. Imagine compressing the mass of our sun into a sphere just a few miles wide. That's a black hole.
The edge of that sphere is called the event horizon, the point of no return.
Once you cross it, nothing, not light, not energy, not even information, can ever escape. Inside, the laws of physics as we know them begin to break down. Space and time lose meaning.
If you were to fall in, you wouldn't be crushed right away. You'd simply lose all paths back through time.
From the outside, your fall would appear to slow down, your light fading, turning red, then vanishing.
For you, time would flow normally, and you wouldn't even realize you'd crossed the universe's final boundary.
Black holes aren't monsters roaming space. They don't hunt or devour at will.
They are the natural outcome of stellar evolution, the final breath of giant stars. When a star exhausts its fuel, gravity takes over and collapses it into a single, infinite point. A black hole isn't destruction. It's the universe maintaining balance at its most extreme. It reminds us that when physics is pushed to its limit, the universe doesn't end, it transforms. It becomes a place where time, energy, and matter merge into a single reality.
In 2019, humanity saw a black hole for the first time, the blazing ring of M87 Temps.
That image wasn't just a photograph. It was a mirror reflecting the laws that built our universe.
Before there was light, there was darkness. And in that darkness, black holes were born. They were not the end of stars, but gateways to understanding creation itself.
Have you ever imagined what a black hole really looks like? Most people picture a cosmic drain swallowing everything nearby.
But a black hole isn't empty at all. It has structure, real layers built by gravity itself.
Imagine you're approaching one, close enough to see how its invisible architecture unfolds.
The first thing you'd notice is the accretion disk, a ring of gas and dust spinning at nearly the speed of light. It's the brightest clue that something unseen is hiding at the center.
As matter spirals inward, friction heats it to millions of degrees, releasing powerful X-rays we can detect across galaxies.
The disk is a paradox, where matter dies, yet shines its brightest in the moment before its fall.
Beyond that glow lies the event horizon, the ultimate point of no return. Cross that boundary, and not even light can find a way back out.
It's not a wall, but a boundary, where space and time curve inward.
To an observer far away,
But for you, falling in, everything feels normal. You cross the horizon in an instant.
And at the very heart lies the singularity, the place where gravity crushes everything into infinite density.
no law of physics can describe what happens there. and it's the ultimate mystery.
Some scientists think the singularity could connect to another universe, or perhaps a white hole.
Still, what we know for sure is that black holes aren't chaos. They're order at its most extreme. Every layer, every orbit follows elegant mathematics, the same laws that shape stars and life itself. When the universe is pushed to its limits, it doesn't collapse, it transforms.
Look again at that iconic image, the orange ring of M87 Cents, glowing around a perfect void.
It's not a picture of emptiness. It's a portrait of structure, drawn by gravity itself.
In its silence, a black hole reminds us that even in destruction,
Because sometimes the universe doesn't end, it simply changes form.
Have you ever wondered what really happens when a star dies, not fades, but collapses under its own gravity? It's one of the most powerful events in the universe, the birth of a stellar black hole.
Our sun won't end this way. It's too small. It'll fade quietly into a white dwarf. But imagine a star 20 or 30 times heavier than the sun. It dies violently.
When that star runs out of nuclear fuel, its core caves in, and gravity wins. In a split second, it collapses completely, creating an explosion brighter than an entire galaxy. And at the heart of that explosion, something extraordinary forms: a stellar black hole. A black hole just a few miles wide can weigh 20 times more than our sun. Imagine packing all of Earth into something no larger than a thimble, and that's the kind of density we're talking about. If one appeared at Earth's core, our planet would disappear instantly, not sucked in, but swallowed by gravity's power. Stellar black holes aren't chaos. They're nature's way of showing gravity at its most extreme.
But how do we find something that gives off no light at all? We search for their clues. The X-rays from gas spiraling into their grasp.
That gas spins so fast it heats to millions of degrees, glowing across the cosmos. Instruments like LIGO and Virgo catch those ripples, the universe's faint heartbeat.
One of the first black holes we ever confirmed is Cygnus X1, 6,000 light-years away.
There, a black hole 20 times heavier than our sun feeds on a massive star beside it.
Across our galaxy, millions of these stellar black holes drift silently through the darkness.
Most are quiet wanderers, unseen, until they meet another star, or each other.
Each collision, each burst of energy, tells us more about how gravity sculpts the universe.
So next time you look up at the night sky, remember, every bright star is on borrowed time. When their fuel runs out, they collapse inward, folding time and space into a single point.
That's how gravity survives long after the star itself has died. Stellar black holes are the universe's way of saying, even in death, there's power and permanence.
Have you ever thought that black holes might not just destroy, but remember? Hidden beyond the reach of light, they may be the greatest record keepers in the universe. Because every black hole is more than a void. It's a storyteller of time.
Everything in the universe carries information, its energy, motion, and composition.
When matter falls into a black hole, it carries that information with it. But if nothing can escape, not even light, where does that information go?
Does it vanish forever, or does the black hole somehow store it?
This is the black hole information paradox, one of physics's greatest mysteries.
If information is lost, it would break one of the universe's fundamental laws.
Einstein's relativity tells us black holes are geometry, bent space and time.
But quantum mechanics insists that information can never be destroyed. And right at the edge of a black hole, these two great theories collide.
Stephen Hawking once made a stunning prediction. Black holes can radiate energy.
This Hawking radiation means black holes could eventually evaporate.
But if they disappear, what happens to the information trapped inside?
Does it escape with the radiation, or remain encoded on the horizon itself?
Some scientists believe it's all written on the surface, a kind of hologram of everything that ever fell in.
If that's true, then black holes don't destroy. They transform. They turn matter into memory, gravity's own archive of the universe.
Every black hole could hold the story of countless stars and ancient worlds.
If we could read their surfaces, we might uncover the history of entire civilizations.
Even today, physicists are divided. Some say the universe keeps perfect records. Others say it forgets.
But either way, one thing is certain: black holes are not the end of the story. They are the keepers of the universe's secrets, the silent librarians of time and matter.
So when you see that glowing ring, the shadow of M8716, remember what you're really seeing.
You're looking at the place where the universe hides its memories. Because maybe black holes don't erase history at all. Maybe they're writing it, one atom, one photon, one moment at a time.
Have you ever looked up at the Milky Way and wondered what holds it all together?
All those stars move in harmony, orbiting something unseen at the galaxy's center.
At the heart of that cosmic motion lies a silent force, a supermassive black hole.
Every major galaxy we've ever studied seems to have one at its core.
Supermassive prime isn't an exaggeration. Some weigh millions, even billions of suns.
Imagine compressing the mass of the entire solar system into a space smaller than Mercury's orbit.
That's what we mean by supermassive.
Take Sagittarius AX, the heart of our Milky Way, 4 million times the mass of the Sun. We can't see it directly, but we can watch the stars that orbit around it.
One of them, called S2, completes an orbit in just 16 years.
There's only one thing that could make stars move that fast: a black hole. But these giants don't just sit there. They shape everything around them.
Gas and dust spiral inward, forming an accretion disk spinning near the speed of light. Sometimes, that energy erupts as colossal jets blasting across thousands of light years.
In that way, black holes aren't destroyers, they're architects of galaxies.
If they feed too much, they blow gas away and halt star formation. If they feed too little, galaxies grow uneven, chaotic.
It's a delicate balance that helps the universe evolve.
And among these giants stands one legend, M87.
In 2019, humanity saw it for the first time, the shadow of a black hole.
That image wasn't a simulation. It was the universe revealing its deepest truth. What we saw wasn't the black hole itself, but the light swirling just outside the point of no return.
That dark center was proof Einstein's black holes are real. Without them, galaxies like ours might not exist at all.
Their gravity stabilizes the galaxy. Their energy controls how stars are born.
In a strange way, they're like the regulators of the cosmos, silent but vital.
Imagine the Milky Way as a living organism, and Sagittarius AX as its heart.
A heart that's been beating steadily for billions of years.
We still don't know how these giants formed. Were they born small or born ancient?
But one thing is certain, they've been here since the dawn of time.
Watching stars rise and die, shaping the galaxies that gave birth to us.
When you look at M87 tags, you're looking at the universe's most patient storyteller.
It speaks not in light or sound, but in gravity and time. Supermassive black holes aren't just the end of stars. They're the foundation of creation.
Even in darkness, the universe finds a way to build and endure.
Have you ever wondered what lies between the smallest and the largest black holes?
Between stellar remnants and galactic titans, there may exist a rare kind of cosmic creature.
We call them intermediate black holes, the silent giants between two worlds. They might be the missing link in the story of how the universe built itself. We know how stellar black holes form from the collapse of massive stars.
And at the other extreme, supermassive black holes shape entire galaxies.
But between them, there's a mystery, a missing chapter. It's like finding pebbles and mountains, but no hills in between.
If supermassive black holes grew from smaller ones, the universe must have built bridges along the way.
Picture something thousands of times heavier than the sun, yet small enough to fit inside the moon. They could consume entire star clusters, yet remain almost invisible.
Astronomers hunt for them in globular clusters, ancient balls of stars on the edge of galaxies.
If something massive sits at a cluster's center, it changes how the stars move.
Others may hide in small dwarf galaxies, too heavy to be stellar, too light to be supermassive.
One example, HLX-1, may hold a black hole weighing 20,000 suns.
If it's real, it's a perfect example of this hidden middle class.
But they're hard to find because they're quiet, too quiet.
Black holes only reveal themselves when they feed, glowing in X-rays as they devour matter.
But a black hole without food? It's practically invisible.
Sometimes, when a star strays too close, it's torn apart in a burst of energy.
Those rare flashes may be our only clues that these giants exist.
If we can prove they're real, we'll fill one of the biggest gaps in astrophysics.
It might explain how supermassive black holes grew so quickly after the Big Bang.
Perhaps these mid-sized black holes merged over time, building the universe we see today.
New detectors may soon catch those collisions, waves in space itself.
Intermediate black holes are the quiet architects of the cosmos. While others roar and burn, they build in silence. Hidden, unseen, but profoundly important.
Because even in the stillness of the universe, creation never truly stops.
Have you ever wondered what happens when you shrink a black hole to the smallest size possible?
Smaller than an atom, smaller than a proton, so small that physics itself begins to fall apart.
To understand them, we must journey to the edge of imagination, the Planck scale. That's a distance of 10 to the minus 35th meters.
Imagine squeezing enough mass into that space. Gravity would twist reality into a subatomic black hole.
But here's the problem. Our two greatest theories can't agree on what happens next. Relativity rules the cosmic scale. Quantum mechanics governs the microscopic. Yet at this tiny frontier, both collapse. Gravity and probability speak two different languages.
That's why quantum black holes fascinate us. They expose the limits of what we actually know.
If one existed, it would be smaller than a proton, but denser than a mountain.
According to Stephen Hawking, even black holes aren't eternal. They slowly evaporate.
This is Hawking radiation. Tiny bursts of energy leaking from the edge of space-time.
For massive black holes, that takes longer than the age of the universe.
But for a quantum black hole, it's over in an instant. Born, lived, and gone in less than a heartbeat of the cosmos.
Some scientists believe these tiny black holes formed moments after the Big Bang.
Others think they could appear during high-energy collisions, even inside particle accelerators.
If they did, they'd evaporate instantly, leaving no danger, only a clue. Detecting one could lead us to something profound, a single theory that unites all physics.
The long-sought theory of everything.
Einstein dreamed of it. Hawking searched for it. And we're still chasing it today.
If the universe is a story, quantum black holes are the punctuation marks at its edge.
They remind us that nature doesn't end where our understanding does.
Beyond the limits of knowledge, the universe still whispers, there's more to learn.
Quantum black holes are where physics bows and mystery begins.
Have you ever wondered what the universe looked like before the first stars were born?
Before galaxies, before planets, before even light itself, there was only chaos.
Those collapses may have formed the very first black holes, primordial black holes.
Unlike the black holes born from dying stars, these were born from creation itself.
Some could be smaller than a grain of sand, yet heavier than a mountain. Others might rival planets in size, ancient relics from the dawn of time.
Scientists believe these tiny relics could be the missing key to dark matter. For decades, astronomers have seen galaxies move in ways that defy visible matter. Something unseen, something massive, is holding everything together. What if that invisible mass is made of countless primordial black holes? If true, then most of the universe could be built from black holes we've never seen. But how can we find them if they emit no light, no signal, no sound?
One method is gravitational microlensing, when a hidden mass bends the light of a distant star.
It's like watching a flicker in the night sky and realizing it was caused by an invisible visitor. Another clue comes from gravitational waves, ripples in space-time when black holes merge.
If we detect unusually small mergers, they could be evidence of primordial origins.
Even Hawking radiation could reveal them, tiny bursts of energy as they evaporate. So far, no proof. But each new telescope brings us closer to the truth.
If they exist, primordial black holes could explain how galaxies formed.
They may have served as the seeds from which galaxies and stars grew. In a way, these black holes could be our cosmic ancestors.
Tiny, ancient, and invisible, but shaping everything we see today.
They would be both fossils and architects, the oldest objects in existence.
They've witnessed everything: the first light, the birth of galaxies, even the rise of stars like our sun.
Maybe they're still here, floating silently through our galaxy, unseen but ever present.
Invisible, eternal, holding the secrets of creation within their shadows.
So when you look at the night sky, remember, what you see is only the surface of reality.
The universe may be built not on light, but on gravity itself.
Because before there was light, there was gravity.
Have you ever wondered what happens when two black holes fall in love?
Imagine the universe's heaviest objects locked in a dance of gravity. They circle for eons, drawing closer, faster, until they finally collide.
That collision sends ripples through space-time itself, gravitational waves.
In 2015, we heard the universe's first whisper, two black holes merging 1.3 billion light-years away.
Einstein predicted it a century earlier, but never thought we'd hear it.
These ripples are the universe's heartbeat, proof that even darkness can sing.
Each detection is a cosmic duet, a final waltz of dying giants.
But not every idea about black holes comes from observation.
Some come from dreams, mathematical possibilities that challenge what we think is real.
Enter the white hole, the mirror twin of a black hole.
If nothing escapes a black hole, nothing can enter a white hole. Symmetry turned inside out, a cosmic fountain instead of a cosmic trap.
Imagine staring into one, a place that never pulls, only releases.
But here's the catch. If white holes exist, they may be too unstable to last.
Any nearby matter could destroy them in an instant.
Some physicists even wonder, what if the Big Bang was a white hole?
A burst of matter and energy, spilling from a timeless boundary.
Maybe every black hole leads somewhere, a doorway to another universe.
A bridge we call a wormhole, linking what goes in to what comes out. If white holes are real, then the universe may not be one way after all.
It could have both entrances and exits, gateways through time and creation.
Black holes could be the universe's inhale. White holes, its exhale. Together, they complete the grand symmetry of existence. Binary black holes show us that gravity can sing. White holes remind us that symmetry can dream. One is proven, the other imagined. Maybe somewhere between reality and theory lies the bridge that connects them.
Because in the end, the universe doesn't just exist, it dances. Have you ever noticed how the universe feels?
Quiet. Not silent exactly, just vast, patient, full of invisible rhythms.
If you could listen closely enough, you might hear it humming.
That hum is the song of black holes. The dark. Every star's life, no matter how bright, eventually fades. Some stars die quietly. Others go out with a cosmic roar. When gravity wins, a black hole is born.
These aren't just destroyers. They shape galaxies, bend light, and sculpt time. Think of stars as notes of the universe, and black holes as its baseline.
Each time two black holes collide, the universe plays a deeper note.
We first heard them in 2015, a faint chirp from 1.3 billion light-years away. These waves are the universe's heartbeat, a rhythm older than stars.
Black holes don't just reshape matter. They reshape our understanding. Inside them, physics as we know it breaks apart. Beyond that horizon, our equations fall silent, but not empty.
They leave us with questions about time, memory, and the limits of knowledge.
What happens to information that falls into a black hole?
Does it vanish? Or does it echo somewhere else in space-time?
Some black holes are ancient, born from the universe's first stars.
Others are titans, supermassive anchors holding entire galaxies together. Sagittarius AX is the beating heart of our galaxy.
Even from 26,000 light-years away, its pull shapes the stars we see tonight.
For all their darkness, black holes are strangely beautiful. They're the universe's paradox, where endings become beginnings. From the death of stars to the birth of galaxies, they bind creation together. They don't just swallow, they compose. Every black hole adds another note to the universe's grand composition. Sometimes, I imagine the cosmos as a symphony still being written.
Each explosion, each ripple, each collision, a bar in a song billions of years long. Somewhere in that melody, black holes keep time, the rhythm of gravity itself.
If you listen closely.
From death to creation, black holes remind us how small we are and how infinite our curiosity can be. Because somewhere out there, in the silence between stars, the universe is still whispering its story.